So hello dear and welcome back. So today we are going to discuss again on orientation because as you have seen, orientation is non-intuitive, and that's the reason we need to understand that how in a most convenient way. For example, I am sitting over the computer terminal and seeing the matrix. How can I perfectly tell? Okay, so this is these are the rotations which has undergone, and the body is actually taking this shape. All kind of things. So it's very exciting story also, and I will try my best to make you understand. In the last lecture, we have discussed that uh, what is the nature of the 3 cross 3 orientation matrix, and also we have told about the matrices uh, of rotation matrices, when nature of the rotation matrices when rotation is taking place any of the principal axis of the inertial coordinate frame, as well as how they will differ when rotation will take place about any of the principal axis of the body coordinate frame. Here we are going to just recapitulate a little bit, and I will introduce you with the concept of composite rotation matrix. So uh, that is our composite rotation matrix. So as you know, this is orientation of rigid body is non-intuitive, and we want to describe orientation of a rigid body using matrix because it is very easy to represent matrix using array in computer. So we want that, and also the strong linear algebra foundation can be also utilized. So that's why matrix representation of orientation is what we are looking for. Now you see, uh, there are two kind of axes. You see, say here is my body, okay, and it's a rigid body, and I have this is body coordinate frame, okay. Say U, V, W. These are the three axis, principal axis of the body coordinate frame. And initially, say we have also inertial coordinate frame, which are perfectly aligned with the body coordinate frame. Okay, they are X, Y, and Z. Okay, actually they are the same. That's why we should not confuse you. In okay, okay, sorry. Okay, we'll redraw it. Okay, so this is simple. Say my rigid body is now um, it has two axes, X, Y, Z, and UVW. So initially both inertial coordinate frame and body coordinate frame are completely aligned. So the transformation matrix, initial transformation matrix between body coordinate frame and inertial coordinate frame is actually a 3 cross 3 unitary matrix. Okay, and then suppose rotation is taking place, first rotation is taking place, about x-axis by an angle, say theta. Okay, this is number one. Then number two rotation is taking place uh, about, say, y by an angle theta phi, and then say another and psi. So these are the three successive rotation this body has undergone. So as you can see now, so looking from here, you have rotated this body, and of course whatever is happening you can understand by an angle theta, and then wherever its body coordinate frame is flipped like this, uh, and then about you have rotated about the y-axis of the inertial coordinate frame by an angle phi. So you are here, and then again um, you are rotating this body by an angle phi, and all kind of like that. Okay, so what will be the final description of the body with respect to inertial coordinate frame? That's all we want, and that is known as composite rotation matrix, and we denote it by C. So C will be equals to, so because the matrix multiplication also can be assumed to be an operator. So initial operator, initially it started with unitary matrix 3 cross 3, and then it is our order dependent, right? So what will be after first operation? What will be the description of the body? You know, I'm not writing 3 cross 3 matrix because you already know, we have deduced that what will be the nature of this matrix when it is rotated about x-axis by an amount theta. Okay, so this is good enough and for um, uh, compact writing. So I am writing it here. Okay, so this becomes my description of the body after first operation. Then wherever the body was, I am giving another operation. We are calling second operation. What is the second operation? I am rotating the body about its inertial coordinate, principal axis of the inertial coordinate from y by an amount phi. So by this matrix multiplication, I will get the description of the orientation of the body when this two transformation has been done. And likewise, say another operation I am giving, uh, you see, like this. So you see, matrix are post multiplied, sorry, pre multiplied. First this, because the rotation is order dependent. So first, this is the description of the orientation matrix. Then whatever is there, then it has to be multiplied by another matrix. So we are going on pre-multiplying them, right? And the resultant matrix, which will be actually three multiplication of three different matrices, which I am not doing, but you already know. Okay, so this is 3 cross 3, another 3 cross 3, another 3 cross 3. So there will be uh, matrices, you know, um, um, nature. Okay, one I can write about x. So 1 0 0 0 0, then cos theta, and then minus sin theta, and then sin theta, cos theta. Similarly, this will be also, you know, about y. So this will be the situation, and then you will have to fill up this. Okay, so it will be say cos phi, then sin phi, and then minus sin phi, and then cos phi, like that. Okay, so this is the way you can write down, and then you will have to multiply them and you get the final description. So this is called composite rotation matrix. Okay, now um, you see this very interesting thing. You see that you, since matrix multiplication are order dependent, you are going on resultant matrix with another operation, then whatever resultant, then another operation, and matrices are pre-multiplied because of this this order which you are doing. Okay, and this is very natural that matrix always will be pre-multiplied. Now wait a minute, when I am telling always, okay, I will have to be a little bit specific that this is not true. Now what will happen when the operations of the body is taking place with respect to its body coordinate frame instead of inertial coordinate frame. Okay, so uh, let us try to recapitulate from our first lecture on orientation, where we deduced the 3 cross 3 rotation matrix. Perhaps you have seen that the description Px, Py, Pz was actually um, rotation. Then the description of that any point on the body with respect to its body coordinate frame. Okay, so this is the position vector of any point with respect to body coordinate frame, position vector of the same point with respect to inertial coordinate frame, and we have deduced it. Okay, also we have told you to deduce, and this is very straightforward to deduce in the same way as you deduce this, that what will happen when you are actually rotating the body with respect to the uh, some of the principal axis of the body coordinate frame. Is it clear? So now what does it mean? I mean, you see, so now say this is our inertial coordinate frame, and initially they were together. Now this is x, u, y, v, and zw, say. Okay. So now instead of rotating about any of the principal axis of the inertial coordinate frame, okay, say you have rotated first with respect to um, uh, uh, u axis of the body coordinate frame. So what will happen? Huh? Say by an angle theta, nothing will happen. Here, instead of the body coordinate frame, it will appear to you that they have been flipped. So you are looking from body coordinate frame. And what you have seen, huh? You have seen, if you remember, that R equal to R transpose, and that is equal to R inverse, because the transformation of these matrices are orthogonal matrices, and that's why transformation are called orthogonal transformation. So this is very, very important. Okay. Now see what is going to happen when we are um, uh, rotating the body with instead of inertial coordinate frame with respect to some of the principal axis of the body coordinate frame. So again, fine. So our C composite rotation matrix will be, so again we are assuming that this is when both coordinate frame are aligned to each other. So this is unitary matrix 3 cross 3. So now you have rotated about, say, one of the body coordinate frame, right? So um, which will be some r this, right? And this is equal to this matrix is equal to r inverse. Okay. So if I just multiply this by another r, so both side I am multiplying. So what is happening? This becomes I, and this becomes R. Say this was my first operation, right? So what you have seen, the uh, uh, the rotation matrix is post multiplied automatically because this is inverse, right? So so you have multiplied here and here. Okay. Similarly, if you have another operation, okay, say R2, okay, so this will be, I can multiply with R2, and this will be again unitary matrix. Okay, so I can erase it. Then again you are uh, giving the operation with respect to one of the axis of the body coordinate frame, and then say this is the third operation. Okay, it will be in a similar way. I multiply both sides. So what you are observing, and this is again um, in matrix. Okay, unitary matrix. So what you are observing, and this could be, okay, say rotation about body coordinate frame by an angle theta. This could be rotation about y-axis of the body coordinate frame by an amount phi, and this could be rotation of um, z-axis of the body coordinate frame by an angle psi. And what you are observing? You are observing that the in this situation matrices are getting post multiplied in the order. Huh? So from so I have shown you it's very easy, and because this is actually what you need to look at. Okay, and you can yourself deduce from this relation, okay, that this will happen. So once you know that, then you can memorize. Okay, so you have deduced it, and you can memorize that. What to memorize? How to compute composite rotation matrix. Okay, and the rule is very simple now. To compute composite rotation matrix, we can, what we have denoted by uh, RC. Okay, so this is equals to, let me clean the board and then okay. So this composite rotation matrix uh, can be calculated by first um, making an unitary matrix 3 cross 3. What does it mean? It means that both body coordinate frame, inertial coordinate frame are aligned. Now say my order is like this. Rotation is taking place about x-axis by an angle theta. So I will pre-multiply. And say my second operation is the body is rotated about its uh, y-axis of the body coordinate frame by an angle phi. So where this rotation matrix will go? It will be post multiplied with reference to the unitary matrix. So it will go here. You follow? And then say suppose you have given another operation. Okay, and since this is also operation is actually you have given with respect to the z-axis of the body coordinate frame, so whether they will be pre-multiplied or post-multiplied, they will be post-multiplied. Say another operation you are giving. What is that? About y-axis by an angle alpha. So where it will go? You can now you know. Okay. Say another operation you have given z by gamma. So it will about z comma. So on and so forth. You can give any number of transformation to the body, and say after 5 such transformation, what will be the orientation, final orientation of the body? The this is the multiplication of the matrix you will have to do. Of course, this is as if you are multiplying with 1, so it's creating no problem, but this is actually a deciding factor, right? So if you follow this procedure, you will never make any mistake, and you will be able to correctly um, figure out the composite rotation matrix with which the body is actually um, orientation of the body will be described. Okay. So let us take a small example again, since you have understood. A small example we will see, and we will see that why matrix, why the orientation of the body is non-intuitive, because there are so many ways to so a body can start from one orientation and reach to the final orientation using so many possibilities. Okay. Now, the example which I am giving is this. Suppose this is the order. You have a body. So this is our body, rigid body. And first operation you have given about x by an angle theta. Second operation you have given about u by an angle, say again same angle. Followed by another operation. Okay. I will not make it more complicated so that you can. So this is the order. So it will be, so initially I need to make a identity matrix that I have done, and then whether to pre-multiply or post-multiply, it will depend on this. So the rotation has taken place about x-axis of the inertial coordinate frame. So this matrix will be pre-multiplied. Okay. So, and you know the nature of this matrix. So here it will be. Okay. Then the another operation, x-axis of the body coordinate frame by an amount theta. So where it will go? Here. Then, sorry, another operation you have given about uh, y-axis of the inertial coordinate frame. So it will be pre-multiplied. So this is the correct orientation matrix after these operations. So the final description of the body can be given by this composite rotation matrix, as you will get by multiplying this matrix, this matrix, and this matrix. And this fundamental matrix, you already know what is their nature. And again I am writing. So uh, you are you just can follow. Now the question is, this you have got, okay? You have calculated the composite rotation matrix. The question is there other operations which will lead to same orientation of the body? So I'm asking you. The answer is yes, and that's the problem. Okay, you see, this is your composite rotation matrix. I can now show you there are several other uh, oriented other operations or orientations the body can undergo, which will lead to same composite rotation matrix. Tell me one possibility. Hmm? Possibility. Possibility one. Hmm? How it could be that body is rotated first about first um, about body coordinate frame. Okay, so body coordinate frame uh, by an angle. So this is my first. Second, third, Possibility 2, first it could be um, the body could be rotated. Hmm. Body could be rotated by its y-axis by an angle phi, followed by a rotation about x-axis of the body coordinate frame by an angle this, and then another. You see, so these are the two possibilities because they will lead to same composite rotation matrix. You can try. Okay, is there any other possibility? Maybe yes. Let us see. Possibility 3. So body can rotate about x-axis by an angle theta, followed by another rotation about x-axis. See, all the rotations has been given with respect to inertial coordinate frame. All the rotations are given with respect to body coordinate frame in this order, and here there is a mixture, but they will result same composite rotation matrix. You can easily see, right? Isn't it? Am I clear? I believe, right? Because here, what you will get like this, and then this is the order V phi, then U theta, then U theta. Since all the rotations are about some of the principal axis of the body coordinate frame, we are actually post multiplying. Sure, and then you see this and this, they're the same. You can just, because the principal matrix about x, about y, about z is actually equal to about u, about v, about w respectively. Okay, so same. So this is what you got. Here also, this is what you got, right? This is the order. This is the order. So you can see there are many. Is there any other way? Let me see. Fourth possibility, fourth. Now it is your turn. Tell me. Ah, Um, first, it could be with respect to um, x theta. So this is first. Then with respect to body coordinate frames, x-axis of the body coordinate frame. So this is our order number 2. Then third about y and phi. So this is another sequence of operation which will lead to same orientation of the body. So you can see it's non-intuitive, right? There are a number of different orientation. Body can start from one orientation, and through a number of sequence of operation, it can go to the final orientation. So from initial to final, say, I'll guess it. Say a body is actually uh, initially the body was like this, and they say then the body becomes So from here to here, so this is initial and this is final, final orientation. Say this is our inertial coordinate frame, then body coordinate frame. This could be our uh, inertial coordinate frame. This could be our body coordinate frame. So what you can see from here to here, there are a number of ways, number of operations you can think of uh, can be given so that it will reach from this orientation to that orientation. Okay. So the question arises: how do I know what are the sequence I should follow? Hmm? What the sequence I should follow? That's the answer we will give in the next class. Till then, stay safe. Have a nice day. Bye bye.